Hey all, in this video we'll go through activity 7, which is naming ionic compounds that contain transition metals. So to start, as a warm-up, we'll name a few ionic and covalent compounds that do not contain these things. First, I have CaF2, which is an ionic compound that's made of a metal and a nonmetal. So to name it, I'm going to simply name the anion, or the cation, which is calcium, and then change the anion to have an IDE ending. This is calcium fluoride. I do not need any prefixes because it's an ionic compound. The second one is covalent, hence the reason why there are prefixes. I have trisulfur hept oxide. So trisulfur tells me that I have S3. Hept oxide tells me that I have O7. So that's my formula. Lastly, I have another ionic compound, aluminum oxide. Since I'm going from name to formula, I'm going to do the crossover method where I write out my two ions. Aluminum has a +3 charge, oxygen has a -2 charge. When I do the crossover method, I turn the charge of one thing into the amount of the other. So since the charge on oxygen is 2, that means I'll have 2 aluminums. Since the charge on aluminum is 3, that means I'll have 3 oxygens. So Al2O3 is my answer for aluminum oxide. Now, we're going to practice working with transition metals. It's worth knowing that at this point we should know pretty much all we need to know about covalent naming, but we still have a lot of work to do with ionic naming. So we're going to spend a large majority of our time focusing on ionic compounds. And transition metals are obviously a major part of ionic compounds because they're made of metals and nonmetals. We've often ignored transition metals because they have a variable charge, and therefore you have to determine the charge before you can determine the name or formula. What I mean by a variable charge is that most elements have a set charge, like this whole row is +1, this whole row is +2, this whole row is -3, so on and so forth. But any of these guys in the middle here have a variable charge. You'll see chromium could be +2 or +3. Manganese, same thing. Iron, same thing. Cobalt, same thing. The only exceptions to this rule are things like zinc, which always has a +2 charge, and silver, which always has a +1 charge. So even though they are transition metals, we kind of don't treat them like transition metals. Some things that are in the other metal category as well, like tin or lead, also get treated like transition metals because they can have variable charges as well. So what do we do with these variable charges? Well, we have to consider that when we write the name, or when we look at the name and want to write the formula, the charge of the transition metal is written in Roman numerals. So for example, iron 3 sulfide, the iron has a +3 charge. I know it's a plus because all of these metals are still before this line, so they're all still going to want, or I guess I should say this line, because they're all still going to want to donate electrons rather than to accept electrons. So iron 3 sulfide has a +3 charge. You can see in your packet a list of the Roman numerals 1 through 10, but you will need to know this. 1 is an I, 2, II, so on and so forth through 10. So make sure you study those. The most common ones are definitely the 1 through 4. All right, so let's practice that. Here we have iron 3 sulfide. Obviously, our iron and our sulfide are going to be our ions. Sulfur has a set charge of -2 when it ionizes. Iron has a variable charge, and we know that ours is +3 because of the 3 in Roman numerals. So my two ions are iron 3+ and sulfur 2-. So when I do the crossover method, I'm left with the formula Fe2S3. Similarly here, I have copper 2 fluoride. I have obviously a copper ion and a fluorine ion. Fluorine is always -1. You'll always know your anion. Your copper must be +2 because it's told to us there. So when I do the crossover method, I'm going to write the formula of CuF2. Each one of these names only matches one formula and vice versa. Lastly, with nickel 2 oxide, I have a nickel ion and an oxide ion. The oxygen always -2. The nickel is +2 because of that number there. So when I write the formula, I'm going to simplify that from Ni2O2 down to just NiO. This is going to be my final answer, not the unsimplified version. So going from name to formula is fairly straightforward with these. Going from formula to name is sometimes more difficult because you have to do the crossover method in reverse in order to determine what the ions are. So to do this, you'll need to write the name of the compound, making sure to put the charge of the metal in parentheses written in Roman numerals, and you may need to assume the charges if they're equal, and I'll show you what that looks like in a bit. So here are some practices. Here we have 4 formulas, and we're going from formula to name. So the first thing that I have is Fe2O3. So doing the crossover method in reverse means taking my amounts and imagining what were they as charges before. So my ions here are, of course, iron and oxygen. My oxygen ion, of course, has a -2 charge, and that's why there's a 2 there. My sulfur, or my iron ion, has a variable amount, and its charge must be the amount of oxygens. So I must have a +3 charge here, because if I imagine this +3, it went down and became the amount of oxygen. So this guy's name is iron 3 oxide. Next, we have one with molybdenum. So again, if we do that same sort of reverse crossover method, we know the charge on phosphorus is -3, and that means the charge on molybdenum must be +2. So this guy is molybdenum 2 phosphide. Next, we have Cu and S, where our ions are copper and sulfur. Obviously, sulfur has a -2 ion charge. And if we look at the formula, we can see that it's been simplified here. We don't see a 2 next to copper. And so that must mean this thing was simplified from 2 and 2 down to 1 and 1. So in order to simplify with a -2, that means copper must have been a +2. So this is copper 2 sulfide. This is what I mean by you sometimes have to assume the charges. Lastly, we have TiCl, where chlorine has a -1 charge. Therefore, titanium must have a +1 charge. So this is titanium 1 chloride. Let's go to activity 9 now in your packet. Flip forward 1 ahead. The good practice ones for you to do today are numbers 6 through 14, number 29, number 36, number 37, and numbers 39 through 42. But I'm going to show you a particularly difficult one, number 11. There are a few that are like this. So with number 11, we have PbO2, and we're asked for the name of this guy. And it can be tempting to just look at this number and say, oh, that must have been lead 2 that made this. But that's not correct, because what we see here is that our 2 ions, lead and oxygen, have been reduced or simplified. How do I know that? Well, it's because there's no number right here next to lead. Let me highlight that. That means oxygen's -2 charge has been reduced into a 1 amount. It's been cut in half. So that means lead's charge must have also been cut in half. What gets simplified to 2 when it gets cut in half? A 4 does. So Pb4 made this. This means this is lead 4 oxide. We can kind of check our work by going the other way and writing lead with a +4, oxygen with a -2, doing the crossover method, and then simplifying. Each name should only match one formula, so theoretically, this and this will always be the same as long as you've got the answer right. All right, that's naming with transition metals. Join us again in another video for naming with polyatomic ions.